Okay, so on to the next session. So here we'll be looking at alkenes. Now for alkenes, remember you have this in your notes already, so I'll just breeze through this. So alkenes are hydrocarbons, we've established that earlier. They form homologous series with the general formula CnH2n. They all contain the CC double bond, and so this is their own functional group. And largely, this dictates their reactions. So, of course, we have looked at different examples. So, because of the double bonds, they are called unsaturated. They are called unsaturated. So, remember, alkanes have only single bonds. That is why they are called saturated. But that's for alkanes. But for alkenes are unsaturated. So remember the first member is C2H4. I'm sure you have that. So you have ethane, propane, butane. So these are examples. So you also draw this table. Okay. Then the same trend, you can notice that there's a trend. So the boiling point increases as you move down a group, right? So it's increasing as you move down the group. That's the boiling point. So take note of that. Now, what are the key points about alkenes? This is the crux of the matter. So alkenes are made from alkanes by cracking. So take note of that. Generally alkenes are made from alkanes by cracking. So this is an example of a cracking reaction. Okay. Then alkanes are more alkene. Sorry, this is a um this is a mistake, this is an error here. So this should be alkenes, E, not A. Okay, alkenes are more reactive than alkanes. Alkenes are more reactive than alkanes. So this should be E, not A. Okay, than alkanes. Because the double bond can break to add onto other atoms. So for example, ethane can add on to hydrogen again to form ethane. So alkenes are more reactive than alkanes. So put down these examples. Okay. So remember, so the alkenes undergo what we call addition reactions. So addition reactions. Remember, alkenes undergo substitution reactions, but alkenes undergo addition reactions. Okay. So you can see this H2O will be added to this. So nothing is substituting. Everything will be added to it. Okay, now for polymerization. So alkenes, okay, undergo addition reactions, and so they can be added to each other. So when they're added to each other to form long chains, we call that polymerization. And those long chain compounds are called polymers. They are called polymers. Okay, so the alkene molecules that are added to form the polymer are called monomers. So your monomers are added to form polymers, and the process is called polymerization. So put this down. Okay, this example. So with this you have polyethylene, okay, polycarbonate, polystyrene, and the like. So many polymers. How do you test for unsaturation? Okay, how do you test for unsaturation? So this is something some of you might be doing. Maybe you might have come across this during your practical. So how do you test for unsaturation? So you use bromine water. Bromine water, okay. So remember, bromine water is orange. Your ethane is colorless, okay. So, but what happens is, if it is unsaturated, then it becomes what? Colorless. Colorless. Remember, you're adding an orange reagent to it, but it's going to be colorless to show that it is what? Adding. There's an addition reaction occurring. So that's it. Bromine water is used to test for unsaturation. Now you can also get isomers. Okay, isomers even with alkanes. So now you notice that there you have an example of isomer. An isomer here is both 1 in, an isomer here is both 2 in, another isomer here is 2 methyl propane. So they all have the same number of carbon atoms and the same number of hydrogen atoms. So you can confirm it on your own. Check it out. So write this down. Okay. Now move to alcohols. Remember we talked about alcohols. So you have an alkyl group and OH. So you must have OH there. Right? So we have methanol, ethanol, propan-1-ol, butan-1-ol. So these are all alcohols. So you can see the formula, the structure. Please put down the table. Number of carbon atoms, boiling point. So you can see here the boiling point also increases as you move down the group. As you increase the number of carbon atoms, the boiling point will increase. So take note, it's the same. Okay, so put this down. We've established this already. Okay, now ethanol, of course, we know it is an important alcohol. So it is widely used all over the world and it is volatile. It evaporates easily. Okay, so two ways to make ethanol. So there are two broad ways. So one by fermentation. So when you ferment anything that contains glucose, you get ethanol. Okay, so you can use yeast. Okay, when it comes in contact with glucose, a process occurs called fermentation. Fermentation is exothermic. So ethanol can be made this way. So we make it from starch, from sugar, from cellulose, and the likes. Okay. Now, but the reality is, you can read up on how ethanol can be made, but ethanol is separated from the final mixture using what fractional distillation. I talked about fractional distillation. Remember in class, take note of that too. So write this up. Now, by the hydration of ethane. So this is another way you can make ethanol. So when you combine ethane with water, you get ethanol. Ethane with water gives you ethanol. Okay, so that's another way to make ethanol. Now, because ethanol burns well in oxygen, it's also used as fuel. Okay, so it's used as fuel in many countries. So that's it with ethanol. Now we look at ethanol does not produce carbon dioxide when it burns. So this is an added advantage of ethanol. So that's it with alcohols. Now carboxylic acid. For carboxylic acid, we are looking at the group where you have alkyl group and COOH. There's a COOH after the alkyl group. So example, you have methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. So here you can see that the form, we've talked about the homologous series already. So please put these notes down. So there are two ways to make ethanoic acid. So ethanoic acid is made by oxidizing ethanol. So when ethanol is oxidized, you can get ethanoic acid. Okay. So then how is it made? So it's made by acid fermentation. So if you can use acid from fermentation, yes, using maybe vinegar and the likes. Another is by using oxidizing agent. So when you oxidize alcohol using an oxidizing agent, you get um a carboxylic acid. Example of oxidizing agents that are powerful are potassium permanganate or potassium dichromate. So they can give you a carboxylic acid. Now, what are the typical reactions? Okay, so a solution of ethanoic turns litmus red because it is acidic. So a solution of ethanoic acid turns litmus red. It is acidic. And a solution of ethanoic acid contains H plus ions because some of the ethanoic acid molecules dissociate in water. So of course, when they dissociate in water, okay, what happens is you have you have partial dissociation, meaning that yes, some of them will break into these two, okay, but some of them will remain like this. A lot of them will remain like this whole, okay, without breaking down. So that's what you mean by a weak acid. So weak acid, you have partial dissociation. Now, ethanoic acid reacts with metals, bases, and carbonates to form salts. So it reacts with sodium hydroxide like this. So you can see how it reacts with sodium hydroxide, okay, to form sodium ethanoate. Sodium ethanoate. So you can have this reaction. Take note of that. Okay. So ethanoic acid also reacts with alcohols to give esters. So esters, that's alkanoates. Okay. So there you have it. So ethanoic acid with alcohol, here is propanol. You get propyl ethanoate. Propyl ethanoate. Okay. So that's it. Now we look at two molecules. So take note of this. When two molecules join to make a larger molecule with the loss of a small molecule, this is called a condensation reaction. This is called the condensation reaction. So then from the above, the reaction is reversible and sulfuric acid acts as the catalyst. So this H2SO4 is the catalyst as concentrated sulfuric acid. Alcohol part comes first in the name but second in the formula. So remember this one attaches here, but in the name of esters, this you start with this. I've talked about it in class already. So there's propyl ethanoate. Okay. So now I think we'll continue from there in my next part.